to my presentation. Today I want to share my research paper titled Solving Two Variables Nonlinear Simultaneous Equations Using a Table. The main idea of this paper are solving nonlinear simultaneous equations may be a challenge to some non-technical students. Some people may not want to spend time solving these equations, although they know how to do it. This paper introduces a simplified way to read off the solutions from a table without going through the procedure. Now let us derive the result. Let's define the following quantities, and these definitions will be used throughout this paper. We define alpha, beta, gamma as a determinant as shown on the slides, and the constant A, B, C, D, E, and F. Now let us look at the first form that involves x squared, 1 over x, x power p, and 1 over x power p, where p is integer. We first put the given set of equations into matrix form. Then we define the determinant of a of x, and a of y in the normal way, following Cramer's rule. Then we use Cramer's rule to get x as determinant of a of x over determinant of a, and y is determinant of a of y over determinant of a. We rearrange the equation for x, and we get a quadratic equation with the solution readily available as a quadratic formula. These two solutions for x1 and x2 are then substituted into the equation for y to obtain the corresponding y1 and y2. Now let's look at a numerical example. Given this set of nonlinear equations, 6x squared plus 4x cubed y equals 11, negative 5x plus 7x cubed y equals 2. We notice this is exactly the same form as the one we just saw. We just read out the constants a, b, c, d, m, n, and p from the given equations, and we can calculate a, b, c, d, and gamma. We put in these known constants into the solution for x. You obtain x1 and x2. Then we substitute x1 and x2 to the solution for y. We obtain the corresponding y1 and y2. It seems that quite a bit of calculations are required in using the derived formula. However, this formula can be easily programmed into Excel spreadsheet. We just enter the 7 constants from the system into the spreadsheet, and the answers will be obtained instantly, like so. I enter A, B, C, D, M, N, and P into the yellow boxes, hit enter, and I get the 2 set of solutions instantly. Now let us look at the second form that involves exponential and logarithm. As before, we write the given equations in matrix form, and then determine the determinant of a of x, and a of y. Using Cramer's rule, we obtain x is given by 1 over k natural log gamma over alpha, and of course gamma over alpha must be positive, and y is obtained using Cramer's rule as well. Let's look at numerical example. Given this set of nonlinear equations, we just read off the constant a, b, c, d, m, n, k, p, and q. Substitute this known constant into the solutions for x and y. We obtain these answers. I put it in my spreadsheet, the 9 constants in the yellow boxes. I obtain x equals to 0.345 and y is 34.540. And in my spreadsheet, I program a verification box. I substituted these x and y values into the first equations. I get 6. into the second equations, I get 7, which are the same values as the given equations. This proves that the answers for x and y are indeed the correct ones. Now, let's look at the forms involving trigonometric functions. As before, write it in matrix form, get the determinant of a of x, and a of y. Using Cramer's rule, we obtain x is 1 over k inverse sine gamma over alpha. It depends on the values of x in radian. The angle kx could be in q1, q2, q3, or q4. Hence, we generalize the solution for x as shown. And this will yield 4 different values for x. We should choose the correct one, 2, or all 4. And by substituting that into the given equations for y, we will get the corresponding y values. Numerical example 3. Given the set of nonlinear equations, we read off the constants, put the constant into the solutions we obtained just now, and we obtain the 4 solutions for x and the corresponding 4 solutions for y. We can't just accept all 4 set of solutions, but should select the correct ones by putting them back into the given equations. This can be easily done using spreadsheet. Like this. I enter A, B, C, D, M, N, K, and P into the yellow boxes, hit enter, and instantly I get a 4 set of solutions. And the verification box there tells me only x1, y1, and x4, y4 satisfy the given equations. Hence, we have to reject x2, y2, and x3, y3. I have derived 65 formulas and I arranged them into a table that I call table of two variables nonlinear simultaneous equation. The left column is the general form and the right column is the corresponding solution in closed form. The first form here involves x squared 1 over x, x power p, and 1 over x power p, and I have 14 formulas. This is the second form that involves square root of x. The third form involves exponential and natural log. The fourth form involves trigonometric functions. And finally, we have a form involving reciprocal of trigonometric functions. As conclusion, the procedure of solving various forms of nonlinear simultaneous equations is completely eliminated. The solution could be read off from a table, similar to table of integral, and then perform some simple calculations to obtain the numerical answers. The arithmetic could be programmed into a spreadsheet, and the answers are obtained instantly. Furthermore, verification of the answers could be done using the same spreadsheet. And this is especially useful if repeated computation is required for different set of constants. Thank you very much. I wish you a good